Hello friends, welcome once again. First few instruction to all students. I hope all of you are joining your respective Google Classroom. If not, then join it. The Google Classroom code is already provided in your WhatsApp group. Please go through it. The second instruction is that this video is only for MSc second mathematics students. Other can leave it. Thank you. Dear students, today we start the first paper of third semester, which is Combinatorics and Graph Theory. As per new syllabus introduced in this academic year, the syllabus copy and teaching plan is already uploaded in your Google Classroom. Today we start the first chapter, which is General Counting Method for Selections and Arrangements. All of you know that the permutation and combinations. Earlier you studied in 12th, as well as some students studied in S5 basic discrete mathematics course also. Here I am giving a quick revision of permutation and combinations. All of you know that the formula of permutation is that NPR is n factorial upon n minus r factorial, whereas combination is NCR is formula is n factorial upon n minus r factorial into r factorial. But the problem is that where we use the permutation formula and the combination formula. I am giving a small example on where we use permutation and combinations. Suppose I am taking a person A, person B and person C, and I want to take a one photograph of two persons. So how many photographs are there? That's great. Most of students give the correct answer, which is a 6. Yes, these 6 photographs are there. First photograph is AB, AC and BC. Similarly, BA, CB and CA. Here note that the photograph AB and the photograph BA are different. Here A is seated on right hand side and B is seated on left hand side. And another photo is exactly opposite that. So we get 6 photographs, 6 different photographs. Here, how to calculate this? When the arrangements or the order is important, when we use the permutation formula, which is a 3p2, 3 person arranged in 2 places, which is 3p2. The answer is 6. Similarly, if you want a group of 2 persons from these 3 persons, so how can we calculate this? So here we get 3 different groups, which is a group contain A and B, the second group contain B and C, and the third group contain A and B. Remember that here the group containing A and B and the group containing B and A, both groups are same. So we get only 3 different groups, which can be calculated by 3C2. The answer is 3. Okay. Then important note is that here, when the order is not important, then we use combinations. Next we see that the explaining addition principle and multiplication principle. The addition principle is that, and the multiplication is that. Here I am giving you some examples on the both multiplication principle as well as addition principle. Okay, welcome once again. Here I give you some examples on addition principle and multiplication principle. You already seen the first part of the video. Now the second part of this video is go through some examples on addition principle. The addition principle is that if there are R1 different objects in the first state and R2 different objects in the second state, and similarly Rm different objects in the M state, if the different objects are disjoint, if these states are disjoint, then the number of ways to select an object from one of these M states is R1 plus R2 plus Rm. Similarly, the multiplication principle is that if in a problem, if if there is OR condition is there, then we use addition principle, and whenever AND is there, we use multiplication principle. All these
statements are given in your combinatorics book, which is Alan Tucker. Okay, we go through some examples. First examples are there. There are two dice are rolled. One is green and one is red. How many? The first solution. How many? So we select pen. Okay. So how many different outcomes of this procedure are? We have to select two dice. We have to roll two dice. One is green and one is red. There are two dice. These two dice. One is green and one is red. These two dice we roll simultaneously. The output of these two dice are we mentioned in the sample set. The sample set is 1 1, means the first dice shows output here 1 and second dice also shows output 1. This 1 1 is okay. Next is 1 comma 2, means the first dice shows 1 and second dice shows output is 2. Next 1 3 dot dot is 1 comma 6, means first die shows 1 output and second die shows 6 output. Similarly 2 comma 1 up to dot 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 2 comma 6. Similarly 3 comma 1 up to dot dot 3 comma 6 is equal to 6 comma 1 to up to dot dot 6 comma 6. These are total 36 different outcomes. So the answer of solution, so there are 36 different outcomes for this procedure. Okay, for this procedure. Okay, what is the probability that? Here remember that when the question is arises as this type, what is the probability that? Okay, what is the probability that? Here remember that this one, which one? The portion, that one is actually the later on portion is actually an event. There are no doubles. That is not the same value on the both dice. So here we write event. Those that the portion which is after that is actually a event. This is event. We write here B is event. Event A is equal is there are no doubles. There are no doubles. Okay, means A set the event A must contain those outcomes from these which will contain no doubles. So A contains all these. Is there is 1 1 is not there. 1 1 is not there. Is 1 2 is there. Both are different outcomes. 1 2 means first die shows 1, second die shows 2. Okay. 1 3 after that 1 6. Similarly 2 1, but 2 2 is not there because both dice says shows same value is not required in that event. Is 2 3 is comma 2 comma 6 and is 6 is not there. Last one is 6 comma 5. So total therefore number of elements in A is equal to 30 because we remove all these. We remove all these 1 1 2 2 after that 6 6 6 6 we remove 6 sets. So therefore number of elements in event A is 30 and we know that the formula of probability of A is equal to total number of elements in event A divided by total number of elements in a sample set. Sample set means where we perform total number of outcomes of that experiment. This is the experiment actually, which we experiment was two dice are rolled. This is our experiment. And total number of elements in sample set is 36. So probability of A is equal to 30 upon 36 is equal to 5 by 6. The answer of probability is always less than equal to 1. Okay, so the answer is 5 by 6. Okay, we go through next example. Five Spanish books are five Spanish different books. Next, French, there are six different French books, and English, there are eight different English books. We have to select in pick of any two. To pick any two. To pick any two from these these three types of these three subject books. So there are three cases. Case 1, either you select one Spanish book and one French book. Case 2, either you select one French book and one English book. And case 3, either you select one uh, Spanish book and one French book. Sorry, one English book. Spanish, English, French, English, and Spanish, French. All these cases are or, either case 1 or case 2 or case 2 or case 3. So whenever or is there, we use addition principle. Whenever there is or is there, we use addition principle. And the problem when there and is used, we use multiplication principle. So when we get a final answer, so we calculate this number of base, add this, finalize this number of base plus add, because of this or, because we for r we use addition principle, and here is and, so we use multiplication principle. Here there are to select one, here we have to select one Spanish book. From there are total five Spanish book, which can be done in 5C one way. Okay, French book, there are six different French book, which is 6C1 plus five, yeah, French book. These are six types of French book, which out of which one is select is and, which is a multiplication. English book 8 different is 8C1, and similarly Spanish book is 5C1 into English book is 8C1. So we get the answer of this. Calculate this is 5 into 6 plus 6 into 8 plus 5 into 8. This is the total number of ways to select two different books of three different subjects. Okay, thank you.